In this video, I'll take up a doubt on mixtures and alligation. A little tough question, not very tough, asked by Sheshwar in our Telegram group. The link to the group is there in the description. You too can ask your doubt there. So let's go to the question. Wouldn't be very visible, so I'll open the file and let's see. So hopefully it will be better now. Yeah. So the question reads as 1 liter of liquid A weighs 1.2 kg. So that's just liquid A. 1 liter of liquid B weighs 800. In 750 ml of mixture of A and B that weigh 720 grams. So there's a mixture of A and B, that is understood. If this mixture and 850 ml of mixture of A and B again. So there's a mixture of A and B that which is 750 ml. There's another one which is 850 ml, and the weights are also given a mix together. Find the percentage of liquid A in the final mixture. And ideally, students, here they should have written here by volume. Okay, because so the tough thing here is we can understand it's something to do with mixtures, but we get confused with the liters and the kg, liters and kg. A typical mixture question that one would have studied would have volumes in it, but then we would be dealing with percentage of milk or water. You know, it's made up of milk and water, the concentration of milk, whatever you call it. Here you don't have that thing, right? So what you realize is the question is asking us volumes of mix, the volumes that are mixed. Okay, and what is the other thing? So this 1 liter is the volume, and what's the other measure? The weight. So the equivalent of percentage of milk in a typical mixture question here is the weight per liter. There we had milk, amount of milk, the percentage of milk in the mixture. Here we have the weight of the liquid, but what weight per liter? So this A is characterized as it is going to weigh 1200 grams per liter. And if I do alligation of such a measure, okay, then whatever comes in the denominator, that will be acting as the weights of the weighted average. Yeah, so I'm saying weights, but that is not the kg weights. That is like how many liters are being added. That will pull and push the weight of the solution. Okay, so you need to be very good with alligation if you need to understand this point. A lot of us would also do it without too much of understanding. Okay, so that's also okay, but if you really want to understand it in details, you should know what we are talking about here. Now the second point here is why I took up this question to discuss is a lot of us are going to waste a lot of time here, and hence I'm asking you, pause the video, try this question yourself. Okay, and you know, just confirm what I'm saying, is it likely to happen or no. So we are going to treat mixture 1 separately. Okay, there is a mixture 1, let's call it, which is mixed with A and B. Oh, the characteristics I have understood is 1200 grams per liter. Okay, and the same thing here is 800. So if in the mixture also I want a similar measure, so how many grams per liter? Now 750 ml is easy. It can easily be converted to a liter by adding 1/3 of it, by adding 250. 250 is 1/3. So add 1/3 of this, that's 24, again an easy number. So 240, 960. Oh, so when I mix them, I get 960 is the weighted average of them. Oh, so if 960 is the weighted average, you can very easily find the ratio of the volumes of A and B. Volumes of A and B. Okay, and we do know that A and B is 750. The total is 750. So if the total is 750, you can get the volumes individually. But the same thing when you try to do it for mixture number 2, the problem here is that the numbers here aren't very nice. In mixture 2, so I'm going to do this here again, 800, and here it's 850 ml measures 860 grams. But I want grams per liter. So you would have to do something like this, 860 grams, but that is for 850 ml. So how much will it be for 1000 ml? Oh, and this is where the calculation and so on will become tough. And so twice we have used this, and we did not have to use it twice, students. This is, and easily one can spend up 3.5, 4 minutes waste in this question, right? It's tempting because it's a simple question. It looks like mixtures, but this is needless, students. Yeah, you only need one allegation and not twice. And the idea over there is also very easy, students. How do you know about all this? Look here. The idea is that if I have some A as mixed with some B to give me, this gives me mixture 1, right? And similarly some A and mixed with some B gives me mixture 2. And we were working on mixture 1 and mixture 2, and then mixture 1 and mixture 2 is mixed to give me final mixture, right? So if this is there, why are we working on this? Can I not just eliminate this and say A and B are mixed and I get the final mixture? So I just need to do one allegation with the final mixture. So I'll just keep it short. So I'll tell you. So in the final, what I understand is I'm not worried about mixture 1 and mixture 2. I'm just saying mixture number 1, okay, by volume is how much? 750 ml. Okay, and its weight is 720 grams. And mixture number 2 is by volume 850 ml, okay, and its weight is 860 grams. Oh, so I know the volumes and the weights all individually, right? And they are mixed. But since I know them individually, I'll just add them up. I'll not go the long way of weighted average and so on. Okay, I'll just add them up and I'll say the final mixture is going to be 8 and 5, 15, 1600 ml. And is going to weigh 1580 grams. Okay, so let me mix A and B. Okay, let me club these two A together, these two B together and mix them once to get this. So A is 1200. Okay, gram. I like to write the unit, students, yeah, because I again tell you that I'm not very sure if you understood that point of why the weights of the weighted average is going to be the volumes. Okay, that comes from what is there in the denominator here, because you're going to multiply this with the weight, and when you multiply this with the weight, when liters is multiplied with volume, that gets cancelled and you'll get weight over volume. Yeah, anyways, let me continue. So this is 800 and the mixing. Now here you can't completely avoid the calculation. Grams per this is going to be 1580 over how many liters is this? 1.6. Now you'll do the allegation. Now in allegation you should also know that I could multiply all the numbers by the same constant. That constant k will appear in the ratio and will get cancelled. So the answer, the ratio of weights is not going to be affected by multiplying all of them by a constant. And since there are fractions, I'll think in my mind of multiplying it with a 1.6 such that the 1.6 gets cancelled. But this seems okay. There are zeros, so that will take care. But I'll also like to reduce it. I see a 400 is present here, 400 into 2, 400 into 3. There's no 400 here, but there's definitely a 40. So I could do that. I could even reduce it this way, students. Yeah, so I'll multiply this and I'll change the numbers rather than 1. So this by 40, the 0 cancels. 120 by 4 is a 30. Yeah, I'll be getting a 30. 30 into this is 16 into 3, 48. A 0 cancels. 80 by 4 is 20. 20 into this is 16 2s are 32. Okay, 1.6, 1.5 cancel, 0, 0, 158 by 4. Oh, that's not divisible, but it's okay. It's okay. Yeah, you can't really anticipate everything. So 4 3s are 12. Okay, 38. 4 9s are 36 and a 2 left over, which will be this. Still, it's not very difficult, no? So 39, let's say 40, this is going to be an 8.5. 32 to this is a 7.5. So this is the ratio here is nothing but 15 is to double of this is 17. This is the ratio of A and B by volume. By volume. So the answer that is needed is, he's asking percentage. So that is 15 out of a total of 32. And this is a fraction, and you should know 1 by 16 is 6.25%. So 1 by 32 dividing by 32 is not a very difficult task, especially like this. You just multiply it by half of that, 3.125. So 15 5s are 75, 7, 30, 37, 3, 18, 1 carryover, 46.875 exact is the percentage that is needed.